Welcome back to Physics Solution Manual, and today we are going to review dimension analysis. So we are going to look the different facets of dimension analysis. One of the major tool is that it can be used to understand a formula, or in another way it can also use to derive a formula. So we are going to find a dimensional formulas for quantities like surface tension, thermal conductivity, and coefficient of viscosity. So you have to understand that these are all considered to be derived quantities. One that they are dependent on the fundamental quantities, which is basically length, time, mass, and so on. So let's dive in. So the first thing that we have to do, we have to understand is the formula for surface tension. So surface tension, the formula for surface tension would be S equal to rho G R H by 2, where rho is the density and we know the density is nothing but mass by volume. So the dimension of density would be, since it's mass, it's going to be m. Volume is nothing but length. Length times height times width, so therefore you have length to the power 3, because you're basically multiplying 3 different lengths. So that would, you have length times width times height, so that gives you volume. So length, width, and height, or 3 different types of length, physical quantities of length basically. Okay. So next up we have g, which is nothing but your acceleration due to gravity, and we know that acceleration due to gravity is nothing but velocity times time, and velocity again. So if you know your formula, you would know that velocity is nothing but distance divided by time over time again. So you have length over time square. And finally we have r, which is radius, and radius is length again. So you are going to, that has a dimension of length, and height, which is another dimension that has length. So substituting all these into your equation, you get rho is m over, oh wait a minute, there's negative sign, I forgot about that. Okay, so L to the power 3 times G, which is L to the power T, L divided by T to the power 2, and then you have R, which is length, and then you have H, which is also length. So basically you're going to, and what about this 2? What about this 2 right here? Well, this is a number, and if you had paid attention to the previous videos, numbers do not have any dimension, so they are dimensionless quantities. Okay, so yeah, and then you have, so therefore you have m, and you're basically going to calculate this. So you have 3 L's here, and then you have an L cube. So the L cube and the 3 L's cancel out, and you have m by t square. So that would be the dimension of surface tension. So that would be m by and then since it's in the denominator, I'm going to bring that up, and I'm going to write it in a So let me just so this is my answer. This would be the surface tension of my, this is the dimension of the surface.